So, dear students, now what we are going to do is that we are going to solve some problems related to ellipse, and I want all of you to please open your notebook as well, so that you can also solve along with me. And as you know, dear students, while I solve, I go a little slowly because I need to explain you each and every point. But if you find your answer before me, never hesitate to let me know so that I can confirm that whether you got it correct or not. So as you see, dear students, the first question is in front of you, and here it is. The question 1. The parametric form of the ellipse, that is 4 into x plus 1 whole square plus y minus 1 whole square equal to 4 is what out of these 4 options? So dear students, the equation of the ellipse we need to just write in a little rearranged manner. So what you see, the equation of the ellipse is given here, dear students. This I can take it from here. So how I can write it is, we can write is that this is equal to x plus 1 whole square divided by 1, because we are dividing both sides by 4. Why? Because to make the right hand side is equal to 1, plus y minus 1 whole square divided by 4 is equal to 1. Correct, dear students? So this is the equation of the ellipse, which is little bit of known form to us. If you recall that we can consider this is you can make an analogy with this thing, capital X square by a square plus capital Y square by b square is equal to 1. You can make an analogy with this thing, in which case what is capital X? Capital X is nothing but lowercase x plus 1, and capital Y is nothing but lowercase y minus 1, and we know that a square is equal to 1 and b square is equal to 4. So as it is the length of the semi-major and semi-minor axis, so we can write that b is equal to 2 and a is equal to 1. Correct, dear students? We take the positive square root. Now, as we recall, what is that, how we can find the parametric form? The parametric form, the best way to write is that we should consider that x plus 1 is equal to cos theta. Correct, dear students? So we can write is that this is equal to cos theta, and y minus 1 is equal to 2 sin theta. Okay, that is equal to a cos theta. A is 1, that's what we wrote cos theta. That is x equal to x plus 1, that is equal to a cos theta. A means what here? A is 1 here, dear students, as we found it out. And y is equal to b sin theta. B is actually 2, so that is why it is 2 sin theta. So what we get? X plus 1 is equal to cos theta. If you see that x plus 1 equal to cos theta, from here what we get? The value of x. So this gives the value of x is equal to cos theta minus 1. So dear students, the moment you see that x is equal to cos theta minus 1, one thing we are pretty sure that either option A or option C is going to be correct. Now, exactly out of these two, which one is correct? For that, we need to find the value of y from this one, that y minus 1 is equal to 2 sin theta. So from here, what we get the value of y, dear students? The value of y we get is the 2 sin theta plus 1. It is 2 sin theta plus 1. So x is equal to cos theta minus 1, that is 1. And y is equal to 2 sin theta plus 1, that is also 1. So we get the correct option as option C. Any smallest question, smallest doubt, never hesitate to let me know, dear students. And if things are clear, then we can move to the next question. And next question will be available to you in another few seconds. So this is question number 2, dear students, and let me read out this question. A point P of an ellipse. A point P of an ellipse is at a distance 6 units from a focus. If the eccentricity of the ellipse is 3 by 5, find the distance of P from the corresponding directrix. This question is based on a very fundamental understanding of ellipse. If you have your basic understanding clear or not, it is a that is what is actually being judged by this question. So dear students, so let us make a visual representation of this problem. If we give a visual representation of this problem, so it will be something like this, dear students. So let me first draw the ellipse. So suppose this is the ellipse, okay, and it has a focus. So suppose let's take the focus of the ellipse is at this point, okay, and we considered the point P be here. This is the point P, and this is the point S. It's a focus which has been informed in the question. And what we know is that PS, the length of this line segment. So let me draw it in a different color. So what you see in the green color, that line segment is actually PS. And according to the question, it is given as 6 units. Correct? And eccentricity is also given. Okay, what is eccentricity? Eccentricity generally denoted by E, and that is equal to 3 by 5 according to the question. Just for though it is not very important in context to our question, as you see the value of E is less than 1, definitely it is an ellipse. Now, the question is that then the distance of P from the corresponding directrix. So dear students, if we draw the directrix, so directrix will be where? So the corresponding directrix will be here, not dear students. So if I can, make a symbolic representation, D1, D2 is the directrix. What you need to find? We need to find the distance of P. If you look into this question, then the distance of P from the corresponding directrix. So that means distance of the point P. Distance means always we know it is a perpendicular distance. Whenever there is a question or whenever there is a statement, the distance from a point to a line, that means it is always a perpendicular distance. Okay, otherwise you can have many distances, but we should only consider the perpendicular distance unless otherwise mentioned. So if I draw that line in blue color, so suppose we draw this perpendicular and M be the let me draw it very properly, dear students, and let M be the foot of the perpendicular. So if we consider M be the foot of the perpendicular, then what we need to find? We need to simple term. We need to find the value of PM. Exactly, this is the question. Or I can say in the other way is that whatever you see in that blue line segment, dear students, that is PM. That value we need to find. And during the when I placed this question in front of you, I said that this is a with this question, how basic you understood that has been actually being testified here. So what is eccentricity? If you recall, dear students, the definition of eccentricity is nothing but the distance of a variable point on that conic from a fixed point, that is the focus, okay, to the distance of that variable point from a fixed line, that is the directrix. So in simple terms, what you can say is that PS by PM, PS divided by PM is nothing but E, which is actually 3 by 5. That is E, that is equal to 3 by 5. Now out of that, we have been, it is already given that E is equal to 3 by 5, PS is equal to 6. So all we need to find the value of PM. So 6 divided by PM is equal to 3 by 5. So from here we find the value of PM is equal to 10 units, and eventually we get the correct option as option D. I hope, dear students, it is absolutely clear. Any doubt at any point, never hesitate to let me know. And if things are clear, then I'll move to the next question. And I'm just giving today simple questions, all on fundamentals, so that you, as we just complete the discussion on ellipse. So I'm giving the very fundamental question here, dear students. Okay, the next question is also based on the fundamentals, and I'm going to place this question in front of you. And here it is. The question number 3, dear students, is here. And let me read out the question for you. Question here is that an ellipse passing through the point 4√2, 2√6 has foci at -4, and the other point is 4, So these are the 2 points, -4, and 4, Then its eccentricity is what is the question. Okay. In simple terms, what we can say is that we need to find the value of E. Dear students, one thing to pretty sure is that you can simply eradicate option A and option D. Why? Because we know that eccentricity cannot be more than 1 in case of an ellipse, and both the values √2 and 10, which are the option A and D, are more than 1. So eradicate these two options, so it's not possible. Now let's focus to the question. If you look into this one, I'm not going to draw any diagram to solve this question. Why? Because your understanding should be so clear on the fundamentals on ellipse that you can just write it down. Okay, so if you notice the equation, the y coordinate of the foci is 0. That says what? That says the major axis is on the x-axis, isn't it? You can visualize, you can write down in your by your own in your notebook. As we see the way I'm concluding one by one. From that coordinates of the foci, we see the y coordinates of the foci is 0. That gives us an indication that the major axis must be on the x-axis. And from that information, what you can write is that AE is equal to, we can write that AE is equal to 4. Correct? That is what is that, the coordinate of the focus, AE, 0 minus AE, 0. And we see the focus is 4, 0 minus 4, 0. So definitely AE is equal to 4. What is our task? Our task is to find the value of E. And eventually, now our task is turned out to be to find the value of A. The moment we can find the value of A, finding the value of E is pretty simple. It is 4 by A. Let's see how we can find it out. Let us consider the equation of the ellipse as. So this is actually information is given to us. I'm just circling it out, dear students. Let us consider the equation of the ellipse as x square by a square plus y square by b square is equal to 1. Let us consider this is the equation of the ellipse. Now, according to the question, what we can write is that it passes to the point 4√2, 2√6. So definitely, what we can write is that from here we can write that instead of x, we can write the x coordinate through which the the ellipse is passing, that is 4√2. So 4√2 whole square divided by a square plus y square, that is 2√6 whole square divided by b square is equal to 1. Correct, dear students? Now, If you recall, dear students, when we know A, B, and E, they are actually tied up with a relationship as long as the ellipse is concerned. And that relationship I'm just going to write in a different color. That is, B square is equal to A square into 1 minus E square. So dear students, what we can write is that from here we can write that B square is equal to A square minus A square E square. A square is square. But what is the value of AE? The value of A is 4. So eventually the value of A square E square should be 16. So from here what we get, B square is equal to A square minus 16. And dear students, that B square equal to A square minus 16, that value we are going to apply in this equation what we derived. So let me come back to the same red color, and I'm just going to write it here. So what we're going to get, dear students, 4 root 2 whole square. So 4 root 2 whole square is actually 32 by A square. 32 by A square plus 2 root 6, 24 by B square. And what is B square? B square is nothing but A square minus 16. And that is equal to what? 1. And dear students, it is pretty simple to find the value of A here. How? If we simplify, then just not even simplification, if we just make a cross multiplication and then rearrange, so we are going to get something like this. 32 A square, sorry, 32 A square minus 512 plus 24 A square that is equal to A square, that is equal to A square into A square minus 16. As all of you are doing in the notebook, in your individual notebook along with me, so you got this thing. Now dear students, so if we further simplify, what we are going to write, what we are going to get is something like this. I need to solve it because it is not very straightforward quadratic equation. So it is something like this. If you simplify, you will get A to the power 4 minus 72 A square and plus 5112 is equal to 0. And if we make a middle term factorization, it is a quadratic equation in A square, by the way, because the power is A power 4 now. So what we are going to get is that A square minus 8 into A square minus 64, that is equal to 0. So from here what we get, dear students, is that A square equal to 64. So from here what we get is that if we take A square minus 64 equal to 0, so we get A square is equal to 64, and eventually we get the value of A is equal to 8. We should not consider the negative value because A cannot be less than 0. And the moment we get the value of A is equal to 8, dear students, we can just apply that value of A here. A is equal to 8 here. And what we get the value of E is equal to 4 by 8. That is actually we get the value of E is equal to 1 by 2. Correct, dear students? Now, you may think, sir, why didn't consider that A square minus 8 equal to 0? If you take A square minus 8 equal to 0, you will see, dear students, the value of A, the positive value of A, what you get. If you apply in that equation A is equal to 4, you are going to get the value of E is greater than 1, which is not possible. Hence, we should not consider A square minus 8 equal to 0. We will only consider A square minus 64 equal to 0. I hope you got it, dear students. And With this note, just by solving these 3 questions, I would like to conclude the class for today, dear students. And I will strongly recommend you to please start appearing the DPPs, the practice test. And I will, before I conclude the class, I just want to tell you that recently that Karnataka CET examination is concluded. And when I was analyzing the mathematics paper happened yesterday, and I was seeing that out of this, all these 60 questions, everything came from our online platform. Each and every question came from our online platform. And I will make a separate presentation and I will share with you. And I will show you that for each question, from exactly from which DPP, which practice test or which module test or which unit test it has come. So that is good information with a very valid data point that why we should make practice in the online test platform. So with this note, dear students, I would like to conclude the class for today, and we will have our class on Monday, same time. And I'll announce on the Monday's class, there will be a physics lecture on Monday, and that is on hydrostatics. One of our physics faculty member will take that class, and I'll convey the details about it later. So with this note, dear students, I would like to conclude the class here now. Thank you very much.
Thank you.
Thank you.